We're gonna move now to example 3. Guys, in this example, I have a dependent motion, and I need to find the velocity of the 15 kilograms block in 2 seconds. Now, if I take a look on this question, the 50 kilograms block A is released from rest, determine the velocity of the 15 kilograms block B in 2 seconds. I would rather think that this is a kinematics example. It's not a kinetics example, because there is no forces here in the question. This question is not about the forces. So I'm gonna think that this is a kinematics problem, and I'm gonna start by solving this problem using the kinematics relation. Let's do it, and let's find out that this problem is both kinematics and kinetics problem, right? So I'm gonna take, as usual, a datum. I'm gonna assume that this is my datum. And I'm gonna assume that this is SB. And this is SE. Now, guys, you can take SB to this point right here, because in fact, this distance from this point to this point is always constant, okay? So this is a beam, it's not a rope. So you can assume that SB is to this point, because this point, the distance from this point to this point is constant, okay? All right, and I'm gonna assume that this is SA from this datum to this level. All right, how to start the dependent motion? It is by stating that the length of the rope is constant. And here, guys, I only have one rope. So this rope is starting from point A to this point, to point D, and to this point, okay? So if I want to find out what is the length of this rope in terms of SA and SB, I'm going to start by SA, right? So SA plus this distance right here, that is C1, it's constant, plus this distance from this point to this point, which is what? It is SB minus a constant length. So plus SB minus constant length, plus this distance from this point, plus this arc right here, which is also C3, plus this distance from this point to this point. And it's always SB minus a certain constant, this constant and this constant, right? I'm gonna say it is SB minus C4 plus this distance here, which is also constant, C5, plus the distance from this point to this point, which is also equal to this distance, which is SB minus C4. So I'm gonna put here 2. And this is equal to 0, equal to constant, sorry, which is the length added. And this means, guys, how many SB do I have? 1, 2, 3. SA plus 2SB is equal to constant. Right? Sorry, plus 3. Yes, you're right. I have 3SB. And in fact, I can deduce that this constant should be 3. Why? Because in fact, if I take block A, it is held by one rope, or it is held by one part of this rope, while B is held by 1, 2, 3 parts of this rope. Okay, so this is my key equation. If I do the derivative now, in order to find the equation of V, I'm gonna have that VA plus 3VB is equal to what? It's equal to 0. And from here, I can find V0A, in fact, or V0B, because I know that V0A is released from rest. V0A is equal to 0, then V0B is also equal to 0, right? And also, I can find the equation of acceleration AA plus 3AB is equal to 0. However, guys, even if I know this equation and this equation, I cannot solve the problem. So guys, the problem is to determine the velocity of block B in 2 seconds. How can I determine the velocity of block B in 2 seconds using these equations? I can't, which means I need to go to kinetics. I need to apply the second law of motion in order to find the answer of this example. So the kinematics relations are not enough. So let's go back. Let's, in fact, apply the kinetics equation. Yes. So how can I apply the kinetics equation? I'm gonna take this one. Just a minute. How can I use kinetics relation in order to solve this problem? In fact, I'm going to take my blocks, each of them as my free body diagram, all right? So I'm going to take first block A. So if I take block A, I have the weight of A, in fact. And I have that A is held by T, which is the tension inside this one rope, all right? And I have that this is the acceleration of A. Why, guys, do I have to take the acceleration of A downward? Why? Because in fact, guys, I have to be restricted to the positive S direction that I indicated early in this problem. So if I took SA in downward direction, I should take AA also in downward direction and AB in downward direction. Guys, if you take AA in the opposite direction of SA, you're not going to have the correct answer. So you always, guys, have to take AA and VA in the same direction of SA. All right? So you always, guys, I'm going to repeat. You have always to take V and A in the same positive direction of S. Now, if the value is negative, then you should flip it. But as a matter of fact, guys, if you take S downward, you should apply Newton's second law by taking A downward. All right? Now, guys, you can have two options, either to apply the sum of forces in the direction of AA or to apply the sum of forces in Y direction. You're going to have the same answer, but I want you guys to see the difference. So the first one, in the direction of AA, what will be the equation? It is minus T plus WA is equal to MAA, right? Now, in the direction of Y, guys, of positive Y, do not forget to put a minus sign before A, all right? So it will be T minus WA is equal to minus MAA because I'm taking AN downward direction, all right? So it is the same, but don't forget to put this minus sign if you took the direction of Y. Now let's take the free body diagram at B alone, as I did for A. You're gonna see that you're gonna have a weight here, okay, and you're gonna have the tension inside the beam TBD, all right, and of course this will be your acceleration at B, okay. Now, this TBD here is the tension generated inside this beam here. Now, in order to relate it to the tension inside the rope, I'm going to take the pulley D, which is in equilibrium, which means it doesn't have any acceleration. It's always in statics. So this pulley here has a TBD and the three tensions, 1, 2, and 3, right? And it doesn't have any acceleration, which means that the TBD here equal to 3t. T is the tension generated inside the rope. Now, what you can do also, if you want to find the relation between the weight, the acceleration of B, and the tension inside the rope, you can take both of these two systems as one system. So you're going to take this block B with this pulley right here. So you're going to take this system as your system, all right? So you're going to sum up these two systems so that you have this block B here with this pulley, all right? So you have the acceleration of B, and you have here the weight, as well as you have 3t, okay? This means that your equation in the direction of AB will be W minus 3t, W of B, of course, minus 3t is equal to MB, B, A, B, okay? All right, guys? So that's it. Okay, so what do I have now? I have this is my first equation in terms of t and the acceleration at A, and this is my second equation in terms of t and the acceleration at B. So what should I do now, guys? What I should do now is to find out the third equation, which is in fact the equation relating AA and AB. All right, so these will be my three equations. And that's why, guys, I advise you to take it in the direction of AA and AB, because this equation is in the direction of AA and AB, which is the direction of S that I took from early in this problem, right? So here I'm going to have three equations, three unknowns, all right? So I can solve for them, and then you can find out if you solve these three simultaneous equations using your calculator. You're gonna find that AA will be equal to 8.544. AB will be equal to minus 2.848, and that T will be equal to 63 newtons. Now, guys, what does this mean? What does AA is equal to the positive 8.5? This means that the acceleration at A is upward. The acceleration is at A is upward because the value of AA is positive. No, it is downward. It is the same direction of the positive S, okay? So don't get confused, please, guys. Now, since this is negative, then the acceleration at B is upward, right? And T is equal to 63 newtons. Now, guys, what I want you to do is to get back to the question. So I know now that the acceleration of B, A, I have a certain values, but this is not the question. The question is to determine the velocity of the 15 kilograms block in 2 seconds. So I know the time, and I need to find the velocity of this 15 kilograms, which is the block at B. How to do this? I know the acceleration at B. Then, since this acceleration is constant, acceleration is constant. I don't have to do the integration button. Since the acceleration is constant, then I can apply the uniformly accelerated motion equation in kinematics to find VB. All right? So I know, guys, that VB is equal to AB T plus V0B. Now, since V0B is equal to 0, because V0A is equal to 0, it's from rest. And since T is equal to 2 seconds, AB is equal to what? To minus 2.84. So it's minus 2.8 times 2. So it is equal to minus 5.6. What does a negative sign B sign V means? That VB is upward. All right? And this is the logical answer, in fact. If you go back here, guys, to the problem, B should be upward. Why? Because, in fact, A is heavier than B. A is heavy. It has a mass of 50 kilograms, and it's held only by one part of this row. B is lighter. It has a weight of 50 kilograms, and it is held by 3 parts of this row, which means A will go downward and B will go upward, and that's why V is negative in downward direction.